Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhd Amierul bin Azizan, and today I would like to present about my practical test 1. Today or now, I would like to present about my practical test 1. Okay, for practical test 1, I get this, which is a windy moment at cutting section. Okay, let's move for the introduction of that. Introduction and also objective. In this laboratory, me as a student need to determine the bending moment at a cutting section. This is my cutting section, and I need to identify which is in this laboratory and the theory one is the same or not. For the theory, we can get it from the structural analysis that we learn in this SEM. And okay, that's all. Okay, that's all for the introduction and objective. For the apparatus, this is my apparatus to pin support. Why I use pin? Because if roller, we will move in the part CX. And we have hanger here and a load. For a load, I use a paper clip. This is my digital force indicator, and this is my special beam because it has a cut section. I think that's all for apparatus. Okay, let's move for the procedure. First of all, I need to sorry to say, because I have no reader in this beam, so I use a ruler for the reader. The cutting section from X, we get 400, and cutting section from right, we get 700, and total, which is a beam span, we get 1000. And from the cutting section to the center, we get 175. We need to use it for get a experimental force. Okay, let's move for the procedure. First, we need to switch on the indicator. After we switch on, we put just a hanger at the cutting section, and after that, we set indicator to 0. It's good to wait for 10 minutes because we will get a better result at the switch on. Okay, then we put a load. For my team, the load we apply is adding by 10 to 10, which is first one we use 10, then 20, 30, 40, 50, and some more. Okay, after that, we record the data, fill it in the table, and repeat it with the load, different weight of load. Okay, in the result, okay, we fill up the table, which is the first one, a load that 10, 20, 30, 40, 50. If I'm not mistaken, the unit is Newton. And we get a load cell. Load cell we get from the indicator, also Newton. The unit is also Newton, or known as F. And experimental, like I said before, from the center to the section is 175. So the load cell we time with 175, we get experimental value. Then a theory that we get from we learn in this SEM, which is the subject structural analysis. And the last one is percentage of error. How can we get a percentage of error? We get percentage of error by the formula theory minus by experimental value earlier, and divide by theory time with 100%. Okay, then we can get the result of percentage of error. Okay, for the discussion, from our laboratory, we as a last team for make this bending moment, so it quite disturb our result because there is several team have done before us, and the result for percentage of error of us is 50%, so it quite high. Like I said before, the several team has done before us, it might disturb the the result of the percentage of error, and also it may disturb our result if we put the load a load and not wait for it to stop, and we just take the indicator result. It also might disturb our result also. And what the hanger also have a weight, so it might disturb because from the weight of the hanger and plus we weight of load, we can get a different result. If we change, it maybe become more complicated if we change the hanger, because not all hanger have the same weight. Okay, for the conclusion, when a load apply, it will have a force, and also if you have a force, it also have a bending moment, except for if hinge. And how can we get the bending moment? So how can we get a bending moment is like we learn in our structural analysis. We use a reaction and we get a reaction, then we can get the bending moment Fy/Fx at the cut section by using a formula submission of Fx, Fy, and also bending moment. All the submission will equal to 0. Yeah, I think that's all for the bending moment. Thank you.